One last thing I'd like to mention about the hydrogen atom wave functions, we kind of looked at visualizing them. What do they look like? How can we understand, where the probability of the electron is? But we can also use these wave functions, just as we have for all the other systems we looked at, to find properties, right? So if we would say want to know what's the average distance of the electron from the nucleus, we can use an expectation value. We can say, well, it'll be equal to an integral, it'll be a triple integral, right, over all space. So in this case, that's 0 to infinity, 0 to pi radians, and 0 to 2 pi radians. And then we can pick, whatever wave function we're considering. So this could be the wave function for a, 3s orbital, absolute value. We would use the R operator, wave function. I said absolute value, meant complex conjugate. Wave function for a 3s orbital, and then we have r squared sine theta, the r, d theta, d phi, and let me move this so you can actually see what I wrote. There you go. All right, so this is how we can use these exact same things that we've done. Is just the integrals get a lot more complicated, right? And so you'll get the chance to practice with things like this in your homework. We'll go over example problems like this in class when we meet together, I perhaps, maybe not right now, I'm making these videos before the semester, but during the semester I think I'll probably record some example problems using my setup here for you to be able to see some examples of how to actually use these wave functions to calculate properties of the molecules we're interested in. Or sorry, the atom, of the hydrogen atom. So it's to show that these mathematical functions have a purpose, right? They tell us something about our system. That's really the important part. So we can do things like expectation values. We can find probability distributions, right? So we can take psi star psi, and we have been plotting that and looking at that, right? So that tells us probability. We can use operators to find, the values of functions, right? If we want to know what's the angular momentum, what's the square of the angular momentum of a psi 3s orbital, we can use that. One advantage is we already know the answer. This is going to be 0 because L equals 0 for an s orbital. Right, and so there are lots of these sort of properties we can find from these wave functions. So everything that we've done with all the other problems we've looked at also apply to the hydrogen atom. It's just now we have more variables to deal with, and the actual mathematical solutions can get a little bit more complicated. The concepts are all the same, though. It's just the details get a bit more complicated.